Welcome back, my viewers. This is the second part of my working with tables tutorial, also known as advanced tutorial number 1. In this video, I will be finishing off the objectives I laid out in the first part. I'm assuming you all watched it already. Without further ado, let's resume. Alright, the next thing we're going to focus on is editing existing tables. Not like literally editing the data, but editing the formatting of existing tables. The main example I will be showcasing is the moves table. Lots of Generation 3 ROM hacks have the physical special split, a feature introduced in Generation 4, and implementing the split requires an adjustment to the moves table. I click the rightmost button here to disable allow multiple rows per line, to make the table easier to follow. First, a quick disclaimer is that this is not what the move table looks like by default. In my move editing tutorial, I had to edit the move table in order to add more move effects to the game. Since I already used the utility, it's already going to be grayed out, but if I click Utilities, hover over Expand, you'll see the Make Moves expandable utility, which is what I did to adjust the table as you see now. The data in the ROM also got shifted to the right by one column when I used this utility. Anyways, back on topic. By convention, the move category is determined by the value of the second to last unused byte in a move's row. This unused field is 2 bytes long, so I'll have to separate it to get my point across. As I'm changing the colon in the unused field to a period, things will go haywire for a split second, but everything will go back to normal once I add a second unused field. That reserves 1 byte. Now that I divided the unused field, I'm going to show you which field you would occupy for the physical special split. It's this column, the one that's currently named unused left. I can take this a step further by renaming the unused left field to category. Notice on the table panel that there is now a category field. You can edit over there. After the period after category, I'm also going to type PS split, which is another list I'm going to add to the tom.l file that will contain the strings for physical, special, and status. Reopening the tom.l file, you can see the changes we made to the move table's formatting. And now I'm going to jump towards the bottom of the file to add my new PS split list. I'm going to give it a name, a default hash, which can be any 8-digit hexadecimal number, and I'm going to define the desired words based on raw numbers, starting from 0. This is the conventional order of move categories, by the way. Make sure when using this notation that the last value, encapsulated in quotation marks, has a comma at the end, otherwise it won't work. Once we've finished, we will now have 3 textual values, 1 for each move category, and the numbers range from 0 to 2. Let's reload the ROM now, so we can see our changes in Maniac Advance itself. We are going to return to the moves table, and now in our category field, instead of seeing raw numbers, every move that you see on screen looks like it's categorized as physical. Yeah, when you're implementing the physical special split like this, you will have to manually go through every single move and change the move category yourself. I know it's tedious, but if there was a utility that changed the move categories for you, that utility would have to make a lot of assumptions that might not necessarily be true about your ROM depending on how many changes you have already made to the moves table. I actually did fully implement the physical special split via a tutorial on Poke Community. It was originally going to be part of the move editing tutorial, but I had to scrap it. But I can show the end result in-game by changing the move categories. So I'll do a few of those in the background. Now I'll load this demo ROM into an emulator. Here's the current move set of one of my party Pokemon, Regirock. In previous videos, all of these moves were physical. But now I corrected their categories, so you'll see Iron Defense and Curse with their status icons, while Ancient Power has the special icon. The move effects table is another area in the ROM that if you mess with moves a lot, you may want to configure on your own. Notice that a lot of the move effects are unused. Even if you implement BattleScript code to one of these unused move effect slots, their unused name will stay, unless you make a change to your tom.l file. There are also unnamed move effects that show up if you expand this table. I have 2 of them. Fortunately, I can reopen the tom.l file again and access the move effect options list that contains all of the names of all of the move effects. As per my move editing tutorial, unnamed 214 is Hex, and unnamed 215 is Coil. You can also change existing move effect names to practically anything you want. For instance, I can change the descriptions of some of these move effects to the name of the move that is associated with this move effect. For instance, what I do with Calm Mind in Dragon Dance. We've returned to the move effects table. By scrolling through the names of all of the move effects in the ROM, you can see the changes we have made in the TOML file itself. Here are the new move effects I made in the other tutorial, Coil and Hex, as well as Camouflage, Dragon Dance, Calm Mind, and Teeter Dance. Yeah, I did a few others off camera. Let's shift gears and talk about how to access some of the tables I have talked about in this tutorial, and in others. Now, when you first start using Maniac Advance, you mainly use it to edit some of the main attributes of your ROM, such as the Pokemon, trainers, moves, and items. This is kind of why we added the 4 buttons here, which are very quick shortcuts to going to those tables that most users would want to edit. However, there are, as you've seen earlier in this video and in other videos, there are many more tables that Maniac Advance can recognize. You can edit quite a lot of things about your ROM. So I'm going to show you how to access obscure tables. So as you know, this is the go-to menu. The find option isn't really a good idea if you're trying to look for particular tables. It's more useful if you're trying to find text or raw bytes of a script. So we're going to stick to the go-to menu. Fortunately, the text box here will allow you to filter your results. By default, when you load your ROM, there are going to be 4 buttons below the search bar: Data, Graphics, Scripts, and Sound. The other buttons you see here are auto-generated by Maniac Advance after doing a couple of things. For the most part, you won't find any tables in them except maybe MISC. The Graphics subdirectory contains sprites and color palettes. Some of them are in tables of their own. The Scripts subdirectory contains really technical stuff, most of which are constants, which are light green numbers, that control things like shiny odds and XP multipliers. The tables in there generally relate to the commands for each scripting language that this game uses. The Sound subdirectory contains tables for sound effects, music tracks, and Pokemon cries. Lastly, the Data subdirectory is where the vast majority of tables reside in, including the 4 tables above, as well as text data, Battle Frontier data, Pokédex data, and linked tables that reference the big 4 that you see here. So to look for basically any table in the ROM, look for keywords, like on a scholarly article database like Gale. If you want to edit type effectivenesses and you search type matchups first, you might not find anything. So you might be able to find it by typing type first, then looking through the subdirectories. I'm not editing any graphics or code, so I'll first look in the data subdirectory for that table. I found the type subdirectory underneath Pokemon, and you might not be 100% sure as to which button to click after type. At this point, you may want to consider synonyms of the words you're trying to input. Conventionally, people refer to the table of type effectivenesses / type matchups as the type chart. So I'm going to try clicking the chart button. It looks messy, but I can guarantee you that this is the right table. There are entries for each offensive type versus a defensive type, besides the neutral matchups, and you're free to edit them however you like. Well, who said that we had to look at the hex content viewer for type matchups? I could just load all the data in the text tool, and all of the matchups are easier to see. I can scroll up and down throughout the left panel, and everything that I need to edit is there except for neutral type matchups. And if you're really curious, the 254 row towards the bottom of the table, that marks the beginning of type matchups that could be affected by the moves Foresight and Odor Sleuth. Most people use Advanced Map to edit wild Pokemon data, but you can use Maniac Advance to do that too, assuming you have memorized which map corresponds to which map bank and map number. In this case, you can start by typing the keyword wild and start searching. Like in the previous example, we're trying to find particular data as opposed to sprites or music, so we're going to go to the data subdirectory again and start looking from there. I click the maps and battle buttons, and I don't think the table I'm looking for is there. How about Pokemon? Oh, I think I found it. It may take a couple of minutes to find the table you're looking for in this hierarchy, but as you continue using Maniac Advance, you will notice that you're finding these tables more efficiently, so you can go easy on yourself. Here's the table of each map's wild Pokemon data, and it's laid out in an easy to follow format. The one catch is that you're going to need Advanced Map to remind you about which map has a particular map bank and map number. I'm going to show you the last example. So you know that when you start a new game, unless you're playing Pokemon Diamond and Pearl, there's a free potion in the PC in your bedroom. I can show you how to change that into any item you want. Unfortunately, the keywords that we have, such as PC and item, don't really filter out a lot of results, so it'll take longer to find what we want, but we'll get there. So for this example, we'll use both keywords and see if that does not filter out the table we want to edit. Instead of 6 subdirectories, we have 3 to choose from. Let's first look at data, and whoa, we have an items button. Never mind, that table is unrelated. The Pokemon button is not much help either. That table is related to moves. I skipped abilities and menus because I don't think those will help. How about graphics? I looked through the buttons that are vaguely related to what I'm looking for, and I don't think that the particular table is here. We can always go back to it if it's not in the scripts subdirectory. So in the scripts subdirectory, the battle button was not much help, but I clicked new game and I think I found the jackpot. You could also do a Control F in your TOML file to look for the keywords there if you really want to. If you looked everywhere in your ROM's metadata and you still couldn't find the table you want, then you can go to our Discord and ask us questions. Perhaps you found a table that we haven't implemented yet, or we could give you the actual name of the table you're looking for. You could also click Help, Online Reference Content, and click List of All Symbols. After hovering over your corresponding ROM, it will take you to a web page that consists of all of the offsets of just about every piece of data in the vanilla ROM. If you search for keywords in that web page, you might be able to find the address of the table you're looking for. If you're ROM hacking, this page is going to be one of your best friends. It has so much useful information, as if it was one of the appendices of a textbook. So now we click the table. Here's the one potion that you get at the start of the game. You can change the item to whatever you please, and you can also customize the quantity. Now if I were to create a new save file, here's what the PC would look like now. When I was recording footage for this video, I was originally going to make this table my demonstration table, but I ended up changing my mind. If you were to implement the mold breaker ability, you would need this table to be referenced somewhere. Next, I'm going to talk more about the mold breaker table and linked tables as a whole. You'll recall that in this table, each ability in the game has one ability field that can be either negate, ignore, or negate to phase. The size of this table is dependent on how many abilities there are in the game, as well as how many bytes each row reserves, and that's dependent on the formatting. And you can see on the left here, ROM addresses are replaced by some of the ability names. For instance, the ability Swarm shows up because the first ability field of that particular row pertains to the ability Swarm. Now, as I said before, this is what's called a linked table, where you have one table, which in this case the mold breaker table, there's an attribute that's being controlled by this, or there's an attribute that's being controlled by another table. I can edit ability data such as the description from this table. Trying to change the ability name actually takes you to the ability names table. Similarly, editing the ability field from the ability names table takes me back to this table. Most, if not all, linked tables have this phenomenon. Another example of a linked list is a list of Pokemon move animations. Basically, to link a table and have all of these names show up, instead of specifying a quantity, you need to put the name of the table instead. As you'll also see, you'll also find other move data in the table of move animation pointers. You can edit this data in the table panel. I could link a table from one subdirectory in another table that's in a different subdirectory. And you can see at the bottom right of the table panel, you'll see the value in the MISC table isolated from the rest of the values in the table panel. Other tables linked to data.pokemon.names, like this table, the evolutions table, are also valid for linking the table that I have currently loaded here. When making linked tables, you can't exactly link two tables to each other directly. Here are the formats of both of these tables, and I color-coded each table name. If you link tables this way, both tables are going to have one element no matter what. And that's actually because of a failsafe that's unrelated to linked tables. Watch me try to expand this table. You'll notice that if I expand either table, you're going to get this unique error message saying that the table length has a circular dependency involving the other table. Other linked tables don't have this problem. If I expand the moves table by one more element, the table safely repoints, and if I look at other tables that reference the move names table, it may be hard to notice, but you'll notice a copy of the second to last element in the table. You'll see this for both pointers to move animations and pointers to move descriptions. And here's why. If I go to the list of move names, which at least one of the tables I was looking at referenced, at the end of the table's formatting, you'll notice a hard-coded number. Thus, at least one of the tables that you're trying to link must have an actual number that defines their quantity, or something like a list of values that you'll find in your TOML file, such as the names of move effects. By changing one of the tables so that it has a definitive quantity, both of these tables you see on screen are now properly linked and can be expanded. I will talk about this table in more detail later on in the video, but another way to link tables is to link them with a constant. Instead of a hard-coded number, this particular table has its quantity defined by a name that's like an alias for that number. After clicking type length in the Go To menu, there's a search results page for all of the instances of that constant. If I really wanted to, I could replace that constant with another constant I have memorized, the shiny odds constant, which is 8. I did have to clear format for the type names after normal in order to get this to work, but here's the end result. I'm definitely not saving those changes. The last thing I'm going to talk about is repairing tables, or rather correcting mistakes in table formatting based on HMA's incorrect assumptions. Just a disclaimer, while I am demonstrating some of these actions on other ROM hacks, I don't actually recommend editing other people's ROM hacks for a couple of reasons. However, there are genuine reasons to open other ROM hacks in Hexmaniac Advance. Maybe there's a bug in the game that you're trying to fix, or maybe there's no documentation for it and you want to either make preparations in your playthrough or provide your own documentation for others to look at. Or maybe you want to file a bug report in Hexmaniac Advance. The thing is, if you don't have a ROM's TOML file, or you lost the TOML file of your ROM hack, then you might need to do a lot of things to make Hexmaniac Advance recognize all of the tables the correct way. For instance, here's a trainer in Pokemon Emerald Omega. The first 4 Pokemon look normal, but what is this Pokemon number 470 here? You can make inferences based on the moveset, but I still want to know the actual species of this Pokemon. Here's the bottom of the Pokemon names table. It stops at Chimecho, but there are a lot of bytes that are in between B0 and EF, so I have a feeling that this is more text data that Hexmaniac Advance is not picking up. To repair this table, I'm going to change the number of entries of the Pokemon names table to a number greater than 412. I recommend incrementing this number by small numbers, such as going up by 40 each time. Oh! Hexmaniac Advance gave me a debug assert. This is not supposed to happen. Anytime you find a debug assert, click this debug button and copy the stack trace. Our Discord has a bug reports channel, and you can paste the stack trace there, though you may need to upload it as a text file. It took me a while to find the right number, and each time I made an edit, I kept getting a debug assert, which was really annoying. Also, since other tables like the Pokemon stats table are linked to the names table, those other tables also got updated to accommodate the new Pokemon that Hexmaniac Advance did not recognize in the first place. Now let's look at some move data in a different Emerald hack. And whoa, what the heck happened to the types? Safe normal, they just look like numbers. Why is that the case? By type 15, I'm going to click the right arrowhead and it will take me to the type names table. And I don't know what happened here. Also, just an FYI, data.pokemon.type.length controls the length of the table, but you're not going to see that table in the ROM. What I have hovered here is something else. Looking at this Go-To menu, there is no button for length directly below type. There actually should be a length button underneath type, but the data associated with it did not get picked up by Maniac Advance. Here's what the constants are supposed to look like. So how do we repair this table? I've encountered this issue before, and I looked at data.pokemon.type.length in the toml file, and if you look at this, it's really convoluted. I don't even know what to edit. I'll just replace this with a hard-coded number and call it a day. Almost there! And finally, I got the table to show all 24 type names, without it glitching out other linked tables. Alright, I have a couple of footnotes to add. First, if you keep finding debug asserts over and over and you're certain that it's for the same thing, you can click the ignore button and get them out of your way for the time being. Also, some older ROM hacks add 5 blank types before adding the fairy type. If you're going to add the fairy type in your ROM hack, you can use an HMA script that only adds 1 type instead of 6. The reason why it was so hard for me to repair that table is because Maniac Advance is trying to protect me from myself. It wants me to make sure that I don't edit other anchors by editing this one, so that's why it tries to throw a lot of error messages. Lastly, the moves icon for Pokemon Emerald Omega didn't load properly because HMA couldn't find a TM palette. Let's show the end results of our changes. So if you look at Altered Emerald's moves table, you'll notice that all of the moves actually show their respective types now. And in Pokemon Emerald Omega, Tabitha's 5th Pokemon was a Rhyperior. A common thing to do when ROM hacking is expanding the moves table. If you do that, but delete or rename your toml file, or you restore a backup without restoring the toml file, this is what the moves table would look like. All moves look like they have 0 base power, most of the types are seen as raw numbers, and the rest of the data looks like it's in the wrong spot of the spreadsheet. Note that the game itself doesn't really notice this oddity, but Maniac Advance will, and this is something you would want to address if you want to keep editing the moves table, or other tables that have had similar issues to this one. So I'm going to fix this by removing one of the unused fields, specifically the one that reserves 1 byte. The table will look further corrupted for a few seconds. I then go to the effect field, and I replace the period with a colon, because the move expansion makes it so that move effects reserve 2 bytes in the moves table. Now we have the correct formatting for this table once again. Alright, we're finally done with this tutorial. This is probably going to be my longest tutorial, because I went into so much detail about the inner workings of Maniac Advance. And also, tables are really fundamental to how Pokemon data structure works in these games. So I decided to give you just about everything there is to know about them, so you can make use of them to the fullest potential while you're making your own ROM hack. All in all, thank you all for sticking around for the end of the second part of this tutorial. You guys are the best. Remember to like, comment, subscribe, and join our Discord so you can interact with our community, file bug reports, submit feature requests, and so much more. That's all I have for this tutorial, and I can't wait to see you all in another tutorial. Take care!